It's a mystery to me.
You know, when you get into mycology is fun because myco means mushrooms, study of mushrooms, study of fungus. You get into mycology, it's like you're an explorer in terra incognita. One book says it's called this, one book says it's called that. The Latin names change all the time. No one really knows. We don't really understand them. We haven't named them all. It's actually like still really open. There's a lot. When you start getting into mushrooms, it's like this is territory that you're explorers in it. It's not that well known. There's very little out there on using these mushrooms medicinally, even though they've been used for a long time. So know that as you take this craft on, you are actually carrying a really important teaching forward. I don't like the idea of, you know, like we're at the top of the species, we're like the most advanced species and other species are under us. I'm not into that idea, but I want to say that mushrooms are a kind of intelligence beyond mammals, beyond plants. Like they're really advanced, like bacteria are really advanced consciousness, exceptionally advanced consciousness. As much as we want to think that they're simple life forms, they're hyper advanced. I mean, the ability to rearrange your DNA at will is pretty profound. Now, you can't really start an ecosystem without mushrooms. Right? Mushrooms are very important to the beginning of ecosystems and may have been the first form of life here. When we are ready to clean up our environment, mushrooms are going to do it. Right? I picked some mushrooms yesterday called shaggy inky cap. That mushroom is kind of popular for this one feat that it does. It can come up through the pavement of streets. It can break up through asphalt. The way that it rises. Now it's a soft mushroom. I mean, you just go like this and you crush it. But the spiraling force that it generates as it structures itself is enough to break up asphalt. Paul Stamets wrote several books. He's one of the more respected researchers on mushrooms in the world. What Paul Stamets came up with was he said, you know, I think the internet grew on the exact same principles as mycelia. In fact, I think it's a synthetic replication of how mycelia grows. So they ran computer models and it turns out it's true. There was an internet before our internet, and that's the mycelial internet. So what happens is these spores, these strange travelers, they drop down and they open up and they start to grow very thin one-cell filaments. Some are positive and some are negative. In other words, some are boys and some are girls. When a boy and a girl find compatible versions of each other from the same species, so one mycelia grows out of a spore, another one starts growing out of a spore, and they touch, they start to grow together, and that's going to start to produce a mycelial knot, which will become the organism. Now, there's mushrooms that live on leaves, and there's mushrooms that live on wood chips, and there's mushrooms that live on food. The ones we're looking at grow on trees. That's called their substrate. They live inside the trees. They're colonizing inside the trees.
Like a root?
Like a root, except that they're made out of, they're really interesting. Now, what happens is they start to grow off these fibers, one-cell fibers. The initial movement is to create a big mass of fibers. Then what they do is they get out their filaments. It's like they lay down the initial major websites. They lay on all these lines of communication. Then the next movement is they start networking those together. Like when you link to your friend's website, who links to a friend's website, and you find one person by following links. This is how your brain works, right? You have all these neurons. So you're little, you start developing neurons like red glowing metal is hot, right? But you might not have connected yet. Then you learn red glowing cigarette embers are hot. And then eventually you connect those two with like, oh, they work on the same thing. Make sense? You start to connect. Mushroom mycelia starts to network itself. And it transmits a lot of information because mushrooms think. Mushrooms think. In the forest, every season the leaves are dropping, yeah? And then they get decomposed. Another layer falls on top, another layer falls on top. Between all those layers, hundreds of layers that the forest is intact, between each layer is layers of mycelia. Mycelium from all different organisms of different types of mushrooms that have completely colonized the forest. Now we don't see them because they're inside the substrate, but they're what's actually going on. There's this massive mycelial internet all throughout the soil of the earth, and nutrients are being moved around from organism to organism as they need to be moved around. Mushrooms are like the gnomes of the forest. They are the keepers of the forest. They observe the forest, they heal the forest, they move nutrients from tree to tree, such that Lots of studies have been done, and they do this. I always wondered how they do this, and I got it the other day in a class I took. Somebody finally explained to me they did it with radioactive nutrients. But what they found out was if a tree is on this side of the forest and 10 kilometers away, another tree over here is suffering from a malnutrition of something, the mycelia will take that nutrient and they'll pass it along the mycelial network, sometimes many kilometers, and feed it to this tree over here. It's reading the whole thing. We have such a limited view, right? Like, we're the intelligent ones and all these organisms are... They are so hyper-intelligent, they steward the forest. They are foresters. They keep the forest.